completing the square has to do with factors, okay? And in the homework that you did the other night, we looked at equations that look like this. Ax minus h squared plus k, correct? And if I asked you how this particular graph shifted, you should be able to say that it shifted vertically, k units, which means up or down, okay? And then horizontally, h units. Okay, and that would be right or left. What does the a do to the equation? Yep, what is that? It's a stretch or shrink, but which direction, vertically or horizontal? Vertical, yep. So it's a vertical stretch or shrink. Now, when I look at a polynomial equation, okay, that looks like this. Is that in vertex form?
Yes, ma'am.
No.
No. Do you remember what form this is called from before? Yeah, this is standard form. Okay? All right. Now, when something's in standard form, do you remember how to find the vertex of it? What did we say? How do you find the vertex of this?
Something equals something.
Yep, there was a formula for H and a formula for K.
KCH was one of them.
Yes, it was. Yes, no, you were right.
K equals C minus AH squared.
There you go. That was, yes, nice job. How do we find the H? Because we do need to find the H.
That was something over something.
Anybody remember the H?
B over negative B.
Negative B over 2A. There you go. Okay? And when you look at this over here, we can tell ourselves what the A is. We can tell ourselves what the B is. And we can tell ourselves what the C is, and then we can figure these two things out. Okay? On this one, it's real easy. We just look at these two numbers, and our vertex is just HK. Okay? All right. Now, we are going to, if we take this and we do something called completing the square, we will be able to put it in vertex form, and we will not have to use these complicated formulas, although you did a nice job of remembering them. Okay? Now, as recall. Yeah. X plus 2 squared. This is a perfect square. Okay? If I multiplied this out, what would it look like?
2 or X plus 2 plus square.
X squared plus 2, 4x.
I'd have to do that, right? And I'd have to FOIL, or I'd have to do a box method.
Do the
Okay.
box. The box. Definitely the box. And then that's X squared at 2X, and 4.
Okay? If I add them all together then,
That's 4X. 4X squared. No.
okay? Let's do another one. Let's do X plus 5 squared. I could do another box.
Squared plus 10 plus 1.
I should have said that too.
X squared, I've got 5x, 25. Okay, so what does it equal?
X squared plus 10x plus 25.
Okay, do you see a pattern?
Yep.
Yes. What seems to be happening? The first term is being squared. Okay? The second term is being squared, And how do I get this middle term?
And
I multiply these two together, and then I do what? I double it.
Why didn't you tell us this like 10 years ago?
And I think I might have mentioned it before, but sometimes you have to hear it a couple of times. In general, it looks like this. If you have A plus B squared, it equals the first term squared plus twice the A times the B plus the last term squared. Every single time. Okay, well, what about if I worked backward? Now let's see if we can do this backward. What if I have x squared? What if I have that? What is that a perfect square of?
X plus 100 squared. X plus 10 squared.
X plus 10 squared?
Yeah.
Okay, so now what if I had this? What goes in that blank to make it a perfect square?
40.
How do you know it's 49?
7
Okay.
and 7.
Yep, you took half of 14 and then what'd you do? You squared it or multiplied it by itself. Perfect. So, 14 divided by 2 squared equals 7 squared, which is 49. That goes in there. So then, what is my equation? X. Okay, that's all we're going to be doing today in completing the square. You need to think of this number, and so we can write it like this so we can see the vertex form. All right, let's do an example. Okay, here we go. Now, what you need to do, first things first, is you need to ignore the 5 for right now, okay? And you're going to write x squared plus 4x. We're going to do that. You're going to put a blank down. We're just going to put the 5 off to the side. Now, what number goes in there to make it a perfect square? 4. Yep, we know it's 4. Now, here's the deal. When you have an expression like this, you can't just add 4 to it because that changes it. But if I add 4 and then I subtract 4, technically, am I really changing it? No, I'm scamming the system. I am doing plus 4 here, minus 4 here, not changing the equation one iota. Now, this part I can write as a perfect square. What is it?
X plus 2 squared.
Good. And then what is this stuff? There you go. I have just changed it from standard form to vertex form. What is my vertex?
Negative 2, 1.
Yep, there you go. Now I know my vertex.
Negative
No, it's always opposite on the inside. All right, we're going to do one more example.
Why didn't you tell us
I didn't really have time, so I wanted to kind of make sure I went over it today.
I want to know why you didn't tell us this like
I think, really? Okay, well, good. I'm glad you guys aren't finding this too bad.
easier than
It was it a lot easier than the other way? All right. Sometimes, you guys, we get a number in front of x squared, and that's where it gets a little tricky. Okay? So, for example, what happens if I have this?
Do you say that every single sentence?
What?
This different is a little tricky.
Gets a little tricky?
They just let us
Okay. Now, in order to do the whole completing the square, the x cannot have a number in front of it. Okay, well, we can't just flat out divide by, but I can factor it out. Well, I can factor it out. Okay, do you see what I did? I took the 4, I put it out front. Okay? And so I took the 4 out of the x squared, I divided the 8 by 4, and now I'm going to put a little blank here because that's where I want to put my perfect square number in. The 3 is hanging out here by itself. So now, what number needs to go in here to make a perfect square? Nope, half of 2 is 1 squared is 1. Okay, now wait a minute. Up here, you guys, right up here, when I added 4, I had to subtract 4. What do I need to do out here?
Subtract 1.
You would think subtract 1, but technically because of the 4 here, I'm really adding 4. So I need to subtract 4.
Tricky.
Okay? So be careful of that.
So whenever there's a number outside and you minus that number,
You multiply that by that, and that's when you subtract. Yes. You just multiply those two and that again. All right, so now I have 4. X, what's my perfect square? Yep, x plus 1. And then what do I have in this? All right, so this one, this equation, what is its vertex? -1, -1. Perfect. What does the 4 do to the parabola? It just vertically stretches it by a factor of 4. Excellent.